is set builder notation, and I'm not super concerned with that, but I'm more concerned about graphing things on a number line. So what you want to do is, whenever we graph something on a number line, there's two different situations. Less than and greater than will always have an open dot. Okay, the reason is that point is not included. If you have less than or equal than, you have an open dot. If you have greater than or equal to or less than or equal to, you will always have a closed dot. That means that point is included. Okay, which means that like here I have x is greater than or equal to 20. This is a closed dot on 20, and then it's pointing to the right. The closed dot means 20 is included. There's a trick for how you graph things, and it works as long as your variable is first. As long as your variable is first when you're graphing something on a number line, the inequality, if you just look at it as if it were an arrow, is telling you which direction to go. But this only works if the variable is first. So next we're going to talk about is solving inequalities by subtraction. Remember, this is just like it was for equations. So don't worry about all this extra stuff. Here, m plus 19 is greater than 56. We don't even have to be worried about this because it's the exact same thing as with equations. Subtract 19 from each side. M is greater than 37. Looking at example 3, here I've got a variable on each side. What in the world are we going to do when we have a variable on each side? Well, it's exactly the same as if we had an equation with a variable on each side. We need to get it to one side. I'm going to go ahead and subtract 3a from each side, which will give me only a's on the right side. So now I get 6 is less than or equal to a. And now I want to graph this on a number line. Whenever you graph on a number line, always make sure your variable is on the left side. So if I want to rewrite this, I want to write it with the a's on the left side. Notice, the inequality is opening up towards a, so it still needs to be opening up towards a when I rewrite the inequality. Which means 6 is less than or equal to a is the same as a is greater than or equal to 6. These mean the exact same thing. Now I'm going to graph it on a number line. Whenever you graph something on a number line, there's only 2 points you need to have as far as I'm concerned. Show me 0, and then show me the number you're plotting. Okay, obviously 6 has to be to the right of 0 but it's because it's positive, but I don't care if it's set perfectly away from 0. Okay, you don't have to measure, just draw 2 lines. Always put 0 on your number line, then put the number you want. Now to graph this on a number line, I need to think of 2 things. What's my circle going to look like, and which way is my line going to go? So here, I've got greater than or equal to. Greater than or equal to means a closed circle, so I'm going to put a closed dot at 6. A is greater than or equal to 6, so I'm obviously going to have 6 on there. Now, since my variable is first, I just look at my inequality to see which way to shade. It's like an arrow pointing to the right, so I just shade everything to the right. What this means is that any number over here, like 7, 27, 300, would work and make this inequality true. And if you think about it, that's pretty obvious, because let's say I pick this number out here, and it's 27, it would be shaded, and if I look at my inequality, 27 is greater than 6, so I must have shaded in the correct direction. So remember, when you're graphing on a number line, 2 things to consider. What kind of dot is it? Is it open or filled in? And which way am I going to shade? And then you can always plug things in to check your answer. And the thing about inequalities is there's going to be hundreds of numbers that work for the answer, okay, instead of just one.